So this video is intended to be an introduction for people who haven't done chemistry before, and we're getting started on nomenclature. So this is a bit of a primer before you go ahead and have a look through the lecture notes for nomenclature. Okay, we'll start just by having a look at hydrocarbons. So hydrocarbons, as the name suggests, are molecules that contain only carbon and hydrogen. Okay, so there's only carbon and hydrogen atoms that are bonded together covalently, and the molecules that they make are called hydrocarbons. Now, the rules to remember when we're looking at hydrocarbons is that carbon makes 4 bonds. Okay, it can be a double bond, it can be a triple bond, okay, or it might make 4 separate bonds. But carbon is always going to make 4 bonds. And you can see this in previous weeks when we're looking at Lewis structures. You've probably noticed that carbon has a tendency, very strong tendency, to make 4 bonds. Hydrogen, on the other hand, makes 1 bond. Now remember, it only needs a duet, not an octet, so it's only going to make 1 bond. Okay, so we always need to remember those rules as we're going through and looking at our hydrocarbons. Here is propane. So propane is a hydrocarbon. You can see it contains nothing but carbon and hydrogen in its structure. Okay, and you can see each bond is represented by a solid line, and we know that these covalent bonds consist of 2 electrons that are being shared between each of these atoms. But how do we know that this molecule that we're looking at is called propane? How do we name these hydrocarbons? What I can tell you is that propane is an alkane. So see, the suffix of the word propane is ane. It's an alkane. And alkanes have the molecular formula equal to CnH2n plus 2. This means that if a molecule has 3 carbon atoms, it can be expected to have 8 hydrogen atoms. Okay, CnH2n plus 2. So in the case where we've got 3 carbon atoms, alright, as in propane, we're going to have 8 hydrogen atoms. So 3 times 2 plus 2 is 8. 3 times 2 is 6, plus 2 is 8. 2n plus 2. Count your carbon atoms, and then you know how many hydrogen atoms you're going to have in your alkane if you follow the formula CnH2n plus 2. Alkanes are distinguished by carbon-carbon single bonds. So we've only got single bonds between the carbon atoms in alkanes. They do not have double bonds. They do not have triple bonds. There are also molecules known as cycloalkanes that have the molecular formula equal to CnH2n. So if this is butane, okay, where we've got CnH2n plus 2, so we've got 4 carbons in butane. That means we're going to have 10 hydrogen atoms in butane. What about cyclobutane? So let's have a look. Here's cyclobutane. Now we've got only 8 hydrogen atoms. So 4 carbons and 8 hydrogen atoms, CnH2n plus 2. So you can see essentially we've had to remove those 2 hydrogens on the end in order for it to wrap around and form a ring. Okay, and this is a cycloalkane. In this case, we're looking at cyclobutane. Getting back to how we actually name these. So, by looking at the number of carbons that we have in our chain, or in our longest carbon chain, we can use a different prefix when naming. So, this is a little bit like a new way of counting to 10. I've actually included 11 here as well, just in case you're curious, but we only really need to go up to 10 for the questions that we're going to be doing. So 1 is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, 6 is hex, then 7 is hept, 8 is oct, 9 is non, 10 is dec. And in case you're interested, 11 is undec. So instead of saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, now we'll say meth, eth, prop, but, pent, hex, hept, oct, non, dec. And this is a little bit like learning a new language. So something that you normally do when you learn a new language is that you learn to count to 10 in the new language. And this is something that we're going to have to learn as well when we're learning how to name these organic compounds, including our hydrocarbons. Okay, so maybe this is something to practice if you haven't seen this before. So for example, name the following alkane. Well, let's count our carbons in our longest carbon chain. We've got 1, 2, 3, 4, 5 carbons in a chain. So 5, I'm just going to go back a slide now. 5 was pent. So this will be pentane. Now let's check the answer. Is this pentane? It is. So we've named our alkane. We've named our organic molecule. This is pentane. Now, another aspect that we're going to have to cover is line diagrams. And you can see a line diagram is just a different way of representing the same thing. So in this example here, in this picture, we've got a line diagram of pentane on the left, and that's next to the full structural formula of pentane, which is on the right. So in the full structure, you can see that we've got all of our atoms are shown and all of our bonds are shown. The only thing that's not shown in our full structure is any lone pairs. It can be, sometimes it is, but usually it's not. Okay, in this case there won't be any lone pairs anyway, but sometimes if we've got, in future, if you've got an oxygen atom in there, it's quite common to leave those lone pairs out. Just looking at that line structure again on the left, you can see that every node on the line structure corresponds to one of the carbon atoms. So there's 1, 2, 3, 4, 5 nodes, okay, and these tend to form a 120-degree angle is a neat way of showing it. So if you imagine if you took a circle and divided that into 3 equal portions, or a pie, and cut that into 3 equal slices, you would then have 120-degree angles, and this is roughly the bond angle that we use when we're drawing our line diagrams. Okay, so what is not shown on line diagrams is hydrogen atoms. It's assumed that carbon always makes 4 bonds. Okay, and wherever it's not shown, we assume that that is going to be a hydrogen atom. Now, in future, we're going to see examples where we've got atoms other than just carbon and hydrogen, and all of these atoms have to be drawn. So any hydrogens that are attached to an oxygen or a nitrogen, they have to be shown, but it's just the hydrogens that are attached to carbon that we leave off our line diagrams. We don't have to draw those. Okay, this is a little bit like a shorthand way of drawing our chemical structures. Let's name the following alkane. Okay, how many carbons do we have in a row? We have 1, 2, 3, 4, 5, 6, 7 carbon atoms in a row, and we know the rest are simply going to be hydrogen atoms. So if we've got 7 in a row, that is meth, eth, oct, let me try again. Meth, eth, prop, bute, pent, hex, hept. Okay, this is going to be heptane. So the name of this alkane is heptane. What is a substituent? So a substituent is any group attached to the main carbon chain of an organic molecule. The main carbon chain, or parent chain, is the longest carbon chain. Any branching groups are substituents. A substituent may be an alkyl group, so it could be a hydrocarbon group. A substituent may be an atom other than carbon or hydrogen as well. So if it's an alkyl substituent, depending on the number of carbons, it's going to have a corresponding substituent name, which is a bit like a prefix, which is going to be used. So instead of meth, eth, prop, bute, pent, it's now methyl, ethyl, propyl, butyl. So a 1 carbon substituent will be a methyl group. Okay. Or a 5 carbon substituent be a pentyl group. So how do we name using substituents? Well, we identify the longest carbon chain, then we number from the end closest to the first substituent. Now this is only for alkanes. In other cases, like alkenes and alkynes, and if there's another Well, you'll understand when you have a look at the lecture if there's another functional group present, so something like an aldehyde or a carboxylic acid or a ketone, you actually number from the end closest to that functional group, okay, that changes the name, including alkenes and alkynes. But in the case of alkanes, we number from the end closest to the first substituent. Okay, we need to identify the substituents, decide what they're called. Then when we name, we list the substituents alphabetically. We put dashes between numbers and words and commas between numbers. And the best way to learn is just to practice these examples, because there's little tricks to it and little situations that arise where you really need to have experienced the situation in order to know what to do when you're naming. So practice these. That's going to be your best bet. Let's have a look at this example. How many carbons do we have in a row in our longest carbon chain? Well, we could count 1, 2, 3, 4. We could count 1, 2, 3, 4, 5, 6. Or we could count 1, 2, 3, 4, 5, 6, 7. Okay, 7 carbons in our longest carbon chain. So again, this is going to be some kind of a heptane, isn't it? Some kind of a heptane. Now, which end do we number from? So we want to number from the left-hand side because that's closest to the substituent. But hang on a minute, what is this substituent called? It's a single carbon alkyl substituent, so that is a methyl group. So if we're numbering from the left, 1, 2, 3, 4, 5, 6, 7, and in the 3 position, we are going to have a methyl substituent, a methyl group. So this is called 3-methylheptane. 3-methylheptane. That is a typing error. That should be 3-methylheptane, not 3-methylhexane. Well, will this correct this? Okay, let's cross this out. 3-methylheptane. There we go. That's much better. Okay, continuing on. Halogen substituents. So as well as alkyl substituents, we can have halogens being substituents as well. So we might have a chloro or a bromo or an iodo or a fluoro group. Let's have a look at some examples. What do we think this is called? 1, 2, 3, 4, 5, 6, 7 in a row. At the 3 position, we've got a fluorine, 3-fluoroheptane. 3-fluoroheptane. Easy peasy. And another example, maybe a little bit trickier. Which end do we number from now? Closest to the first substituent. Now we're going to actually number from the right-hand side. 1, 2, 3, 4, 5, 6, 7. Looks like here we've got a 2-bromo, 4, 5 fluoros. Okay, at the 4 position and the 5 position there's a fluoro. Okay, now we need to decide which one to list first. You actually list these alphabetically. Now because bromo starts with a B and fluoro starts with an F, we need to put the bromo first. And also we need to consider that, okay, this is a 4,5 difluoro, but even though we're naming this as a 4,5 difluoro compound, we don't look at the D for di, we look at the F for fluoro. So here's the answer, 2-bromo 4,5 difluoroheptane. We put the bromo first because B comes before F in the alphabet. We don't look at this D, instead we look at the F and we say, okay, B comes before F, so it's 2-bromo 4,5 difluoroheptane. So the numbers don't need to be consecutive. In this case they are. It goes 2 followed by 4 followed by 5, but it doesn't have to be this way. What's important is that the substituents are listed alphabetically. Moving along. We've covered alkanes. Let's have a quick look at alkenes and alkynes. So alkenes have the formula CnH2n, and they have a carbon-carbon double bond in their structure. Alkynes have a carbon-carbon triple bond in their structure. They're CnH2n take 2. And when naming, the position of this double or triple bond must be considered. So here's an example. how many do we have in a row here? How many carbons in the longest carbon chain? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons in the longest chain. And do we number from the left-hand side or the right-hand side? In fact, we number from the right-hand side because this is closest to where the double bond is. So at the 3 position, we have a double bond. So we always quote the number where the double bond begins. So the double bond is really between carbon number 3 and carbon number 4, but we say that this double bond is at carbon number 3. So if we've got 8 in a row, some kind of an octane, okay, but it's not an octane, it's an octene because it's an alkene. It ends in ene instead of ane, and we have to say that the double bond is at the 3 position, so it's going to be called 3-octene. 3-octene is the name of this molecule. Moving along, here's a challenge question. So if you've been following along and you're thinking, yes, this is easy, this one's a little bit trickier. Now, how many do we have in the longest carbon chain? 1, 2, 3, 4, 5, 6, 7. Do we number from the left-hand side or the right-hand side? Now remember what I said before, is that only for alkanes do we number closest to the first substituent. If it's an alkene or an alkyne, or it's got some functional group that's changing the ending, changing the suffix, if it doesn't end in alkane, there's something there making it end in ene, or it might be making it end in ine, or it might be making it end in ol if it's an alcohol or something like this. Whatever's changing that suffix, we need to number from the end closest to it. So in this case, it's going to be an alkyne. We number from the end closest to the triple bond. So we number from the right-hand side. 1, 2, 3, 4, 5, 6, 7. So at the 2 position, we've got our alkyne. So some kind of a heptine. Okay, so working backwards, it's quite often easier to work backwards. So let's start with heptine. We might write down these so that we can keep track of what we're doing. Some kind of a heptine, okay, it's actually going to be a 2-heptine because that triple bond is in the 2 position. So it's going to be a 2-heptine. And what else do we know? So 2-heptine, we've also got 4,5-dichloro, and we have a 4-bromo. Because bromo, B, comes before chloro, C, alphabetically, we'll put our 4-bromo first. So it's going to be 4-bromo, 4,5-dichloro, 2-heptine. But we've got a methyl group there as well. So M for methyl comes last. Alphabetically, because we've got C, we've got B, and we've got M for methyl. So in this case, it's going to be 4-bromo, 4,5-dichloro, 6-methyl, 2-heptine. Alright, 4-bromo, 4,5-dichloro, 6-methyl, 2-heptine. Okay, so hopefully you're able to get that one on your own. If not, practice, practice, practice. There's plenty of tutorial questions there to practice. Okay, after having a look at this introduction to hydrocarbons, this quick introduction lecture, you should hopefully find the nomenclature lecture a lot easier. And good luck, and I'll see you in class.